Hey everybody, Adam Savage here in my cave with another one-day build, and I'm actually really excited about this one because it's some pretty cool shop infrastructure. If you've been watching recently, you know that I've been sort of having a renaissance with my milling machine and my lathe. Big honking chunks of cast iron that allow you to make things in very incrementally tiny ways, super precise machines. And as such, I've actually been outfitting both to a higher degree than I've ever done before. And these three chunks of steel are part of that process. These are three vices for my lathes. They're called chucks. They're circular chucks. And for most of the time I've had my lathe, I've only used this 3-jaw chuck. But I've always had this 4-jaw chuck, and I recently got a backing plate for it and mounted it to that. And I also recently got an inexpensive eBay purchase, one of these collet chucks, and I'm finding it actually to be pretty precise. And all of this is increasing my ability to use my lathe under lots of other circumstances that I haven't even tried before. But it also begs an important question, which is, how do you store important things like this that are both heavy, need to maintain some cleanliness? You don't want them sitting there gathering dust and grime and cooling fluid and oil in the shop. And yet, this is like, that's got to be 40 pounds. Yeah, that's about 40 pounds, and I think this is a light one at about 25 pounds. How do we store these? Well, if you look up chuck storage, there are as many different solutions as there are machinists, and today's build is a super niche build. But we are going to build a rolling stand that holds these chucks. And we're going to do it all using one of my favorite engineering materials that I haven't done a one-day build with before, 1-inch thick plywood, which they happen to carry at my local lumber yard. We are also going to do this all tab and slotted together. Yeah, it's going to be exciting. 9 pieces of wood, a few holes, and you could literally do this entire build with just a jigsaw and a drill if you needed to. I like these kind of builds. So, oh, I almost forgot. We are also going to use a piece of equipment I have never used in the shop, and I've had it for years. Well, what could it be? Well, it all involves how to make this precise hole pattern of a D1-6 cam spindle lock. Let's get started. Like a lot of builds, this one begins with some drawings that I made in my sketchbook to sort of work out my thoughts. And per usual, the first drawings, this very first sketch I made here, isn't awesome. I don't love it, but it allowed me to kind of play around with some of the spatial relationships of these giant hunks of metal. And look, space is at a premium here. I always need to reduce the footprint of things I store here. And that footprint can be reduced in many different ways. I could have something that's wide and long as maybe I could do something on top, store something on top of it. Or I could have something that's tall and thin as long as it's stable, and it would tuck in different places. And actually the latter is how I'm thinking about storing these chucks. When you're doing tab and slot stuff like this is where, you know, the wood, you know, 2 joining pieces of wood have matching slots and they sock together. When you're doing this kind of work, everything's interdependent. And so it requires some real, like drawing actually really helps me understand how this slot is going to meet this slot and going to interface with that other slot. And then in some cases, I have 3 separate pieces of wood that are all like funk together. And it's a bit of a brain bender. So actually even on this list, I have things like cut this 4 inches deep and then figure out the slotting once it's actually cut out. But yeah, I think I have my first cut list, which is the main faces of the pieces that are going to hold on to the chucks themselves. So the chucks will sit on a plywood face that's 6 by 8 inches with 6 holes in it, and then thunk sits right down in there. All right, I think it's time to start cutting. Great. And that. Wonderful. I have prepared 3 1-inch faces to receive 3 chucks. I plan to have 4 in my collection. I'm wanting to buy a 6-jaw chuck, but even with 4 chucks in my shop, I'm always going to have 1 mounted to the machine, so I only ever need to store 3. So let's get ready to drill and cut these 3 pieces. All right, this is a rough and tumble version of what I'm going to do to these 3 blank pieces of wood. I'm going to cut 2 slots here and drill 6 holes to receive the chucks. But I'm going to use a piece of equipment that I have not used for woodworking before on camera, and that is the Bridgeport milling machine. It is a fantastic woodworking tool. You just need to accommodate it in some ways, and it affords some stunning results. I'm going to make my 1-inch slots here using this 4-flute 1-inch end mill. It's going to be awesome. However, when you do that, as the end mill's breaking through the end of the wood, it can do all this chip out and destroy the face of the wood. So I've actually cut 2 extra frangible pieces. So these are my hero pieces, and I'm going to sandwich them between these 2 so that I can cut the slots and my 3 middle pieces stay sacrosanct. I am mostly set up for this cut. I've got my work clamped into the vise. I have used a guide to make it perfectly aligned with the left side of the vise, and I have marked my center and zeroed out my center on the digital readout. These 2 slots are going to be 1.3 inches apart, which means that for 1-inch deep slots, I'm going to move 1.8 inches off center. That's 1.3 plus half an inch, half the diameter of the milling bit here. And I've also got my frangible pieces here, these 2, which are just sacrificial, and they will take all the damage from the cutter breaking through. And then once I make this cut, the first cut, then I'm going to undo the vise, pull it out, and I'm actually going to turn it, instead of turning it this way, I'm actually going to turn it this way. And the reason I'm doing that is because even though I've worked really hard to mark a perfect center, I might be slightly off. And if I turned it this way, clockwise facing me, I could be a few thousandths off, and that could make construction or assembly difficult later. So in order to make sure all my pieces are really dialed in, I am going to maintain the same distance from the left side and use the same method on the vise for lining it up. I think we are ready for making this cut. So 1.8 inches off center, 5, 6, 7, 8. I'm wrong. Why am I wrong? 1.3 plus 0.5, that doesn't, oh, wait. Half of them, right. I'm sample cuts here. We're just gonna double check that my math is right. There we go. Okay, there's that. Now the distance between those 2 should be 1.3, and if it is, and we are equidistant from both ends, then I'm good to make those cuts. And this looks, yep, like it's exactly 1.3. And then this distance is, let's see here. Okay, 1.2. Yep, that looks good. All right, I think we're good to make our cuts. Maybe you want a better shot. All right, my slots are made in all three of my pieces. The frangible pieces, you can see how much damage there is to the outside when it breaks through. This is basically the equivalent of putting a piece of wood under something you're drilling on the drill press so it doesn't chip the wood as it comes through. So, yes, it is a messy process for your mill, but I'll break out the vacuum and clean it up. Before I continue, I'm gonna clean just the little bits of wood swarf here on my linisher. Something's wrong. What the hell? What the hell? Let's figure it out, mark it out. I know what I did wrong. Obviously I screwed up the cuts, but the way I screwed them up was by not following a bit of important shop practice, which was I didn't lay out where I was cutting. And thus I made a wrong cut on the digital readout, and I didn't think to double check my measurements because I was just going on automatic pilot. Laying out means draw out and shade where you're cutting. This allows you before the cut to make sure that all of your pieces are cut from the same side of both sides. And again, your layout doesn't have to be 100% perfect, but it is a great last double check against using the dials and the measurements of the machine. I think I was cutting to 1.15 and I ended up cutting to 1.25 or something like. Look, I screwed up a number, but ultimately what I did was I didn't give myself a guide as to what I thought was about to happen. So both of these shaded areas describe the length of the channels that I'm going to cut. So I pre-cut 3 new pieces, going to chuck them into the vise and take care of it. Two sides of my vise weren't meeting. So when I was lining up my pieces by doing that, I was actually lining them up on an angle so they weren't matching each other. It is a small difference, but small differences are what make the difference. A bunch of small differences makes a big difference. So I got the vise dialed in. I'm going to refine center. I've got my piece laid out. So I think it's time. Okay. Well, let's refine center. So this is 5.85. I'm really going to center this puppy up. Okay, 5.85 divided by 2. Gonna get this right above. Yeah, okay, that feels really good. So we'll zero that out. And then we'll go 2.925. 2.92. Now that is my layout. I'm sorry, I have this in the way. That is my layout, my pencil marks on my piece, helping me understand that I was not perfectly exact. That's really great. That's why you lay out. That's why you have those pretty little pencil marks right there. See that? See those? Those helped me. They just saved my ass from making the same mistake a second time. Measure once, curse twice. Right. I think we did it. All right, here we go. frangible pieces are gone. So we have our pieces. Let's see if I turn them. Do I still have the same orientations? And it looks like I do. It looks like they are symmetrical. Great. I'm gonna clean them up on the linisher. It is time. I know I kind of led you to believe that the milling machine was the new piece of equipment I had not used before for woodworking, but that's not the case. It's time to drill this hole pattern. And again, each of these vices will sit on these plates and the hole pattern matches up. So the spindle, the spindle pins can actually sit in there. But drilling 6 holes in a perfect radius is a non-trivial yet common thing we need to do in the shop. And the standard way to do it would be to lay it out using protractors and compasses and figure out the positions of all of these. And sometimes you might consider stacking 3 pieces together. You might consider drilling one and using it as a guide for others. All of those are reasonable techniques. But I'm about to use one that's going to take a far lower amount of time and be much more highly accurate. The difficulty with doing layout is it requires experience. There are ways in which your material can move that doing layout and like drilling these holes by hand, you can introduce errors to the process. As you've seen me do here, you can make small errors that have big effects later. The pins are about 7/8 and these holes are about 1 inch. So there's plenty of room for slot, but even still you could get into trouble, and I have many times in the past. No, in order to lay out these holes, I'm actually going to use the built-in computer inside the digital readout that I have attached to my mill. And I've always known that the DRO could actually do this, could give you a hole pattern. I have never realized just how easy it was until I tried it a couple of days ago. And we're going to do it right now to make 3 plates that are perfectly drilled out. I have located center on the piece. And now we're going to use the digital readout and a Forstner bit to make these holes. So bring this up, remove the center pin, add a 1-inch Forstner bit. I have a piece underneath my, I have a piece of wood underneath to, again, to stop the blowout on the other side. So here's what we do. We say F4, I'm going to make a circle pattern. Where's the center? It is at 0 and 0. Enter. All right, here we go. F4, making a hole pattern, center. X is 0, 0, 0. Enter. Y is 0, 0, 0. Enter. Down arrow. Diameter for the D1-6 Camlock spindle is 5.25, so we do 5.25. Enter. Diameter 5. Oops. 0.25. Enter. Oh, right, down arrow. Number of holes, 6. Yes, down arrow. Starting angle. Now, your DRO may have different starting angles. On mine, starting angle 0 is to the left, so I'm going to say 0, down arrow. End angle, 6 holes, right? Because you could distribute 6 holes across only 180 degrees of your circle. We're doing 6 across the whole thing, which means the last hole goes at 300 degrees. So I've actually already tested this. So there it is at 300 degrees. Down arrow, hole 1. Now here's where this guides me to where the holes are. So watch this. This is totally awesome. say 0. Go. And I've lined it up with the edge of my vise. So here you go. That is a perfect 6-hole pattern. To double check, it fits beautifully with the pins of the vise. Yeah, and now, in order to redo it, to do it again, I simply, I'll turn over my frangible piece, clean out the vise so that there's no swarf in there to inhibit my measurements. Go. Put the Hero on, line it up with the edge, and to be honest, I can start with hole number 6, and here we go. Okay, so that is all 18 holes drilled in the 3 Hero pieces, and let's just, if we want to see if everything is radially and bilaterally symmetrical, we'll take 2 of these and hold them up to each other, and we see that the hole and slot patterns match. We'll turn it 90 degrees. We'll see that the holes and the slots still match. We'll actually flip it. Ooh, the holes and the slots still match. I can see they're here and there. They're off by the tiniest bit, but it's consistent. Yeah, look, there are small inconsistencies, just ever so slight. Actually, no, I was just holding it wrong. This is beautiful. And the whole thing took me about 15 minutes to drill all 3 pieces out perfectly. I'm in love with this thing. This is like my new favorite toy. There are just some really cool possibilities when I can utilize this and not have to break out my rotary table to do stuff like this super accurately. As you can see, leaves a little sawdust on your mill, but I believe that is a small price to pay for the amount of time it's saved. I'm going to throw out all the little scraps, even my frangible test piece, because I don't want it, it's not exact to the other 3, and I don't want it confusing me. So yeah, time to do the layout on the big uprights for this stand. All right, so now I'm getting ready to lay these guys out. Okay, I have laid out the basic structure here. I've only drawn one of the 2 sides that will hold these faces, and that's how far apart they'll be. And one of them comes past center here, so I'm gonna have to, in order to cut them out and make sure they're exact, I'm gonna cut them together, and I'm gonna use double stick tape to hold the 2 pieces of wood together. However, I can't just rip this plywood and then do that, because here this front part comes past center. So I need to cut and then do a slight diagonal and then flip. It's a little bit of a thing, but I think we're ready to start cutting out some wood, and that's exciting. Okay, campers, we are barreling down on this. I am almost ready. I'm almost ready. Okay, so first things first, I want to just do a couple test fits. This is the base. That's the rear, that's the front. So the rear sits there, rear brace sits there, front brace sits there. Great. This, okay, that goes cool. Know that those fit. Those, good. That's great. Oh, good. Okay. Whew. This is going to be so freaking fabulous. These guys sit there, so I'm going to they sit right about there, and I'll mark that. And this guy sits here, and I'll mark that. Yeah, about the same. So there's a lot of moving parts to this, but I think the best thing for me to do is to get the rear brace on. That's an inside, yeah. Okay, let's do that. Let's and let me just double check. That's an inside, and that's an inside. Yep, yep, yep. Okay, so that means this one goes here like this because I want to be able to read it. Fabulous. Here we go. This thing's going to be like world-beatingly strong when I'm done. I mean, this just like, you won't be able to take this apart. You won't even believe it. Oh my gosh, yeah. So, there's that. Put that in there. Bring this all the way in. Nice. Great. I'm using a thin layer of glue, thinner than I usually do on this, simply because I am press fitting, and the tolerances on this are actually quite tight, so I don't want too much glue to squeeze out. So here we go. Yeah. Okay, so now I do the fronts piece, and I can do that. Yeah, and that goes in there. Great. Now I can mount it to the base. Front, rear. Great. Okay, so now I've got that. Let's glue it up. Oh my God, this thing is literally going to be like one of the strongest things I have ever built. Oh, right, I can do the sides of these things too. Oh. Front, base, top, front, good. I can't check too many times. All right, there we go. We're doing really well. This is going together nicely. Let's see here. This. So, how does that look? Yeah. Oh, yeah. Oh, yeah. This ain't never going nowhere. What does that mean? Okay. Oh, I love that sound, that solidifying. Okay, let's just double check and make sure. I built a version of this on Saturday, a couple days before now. And like, I actually almost considered it done. And then I started thinking about the fact that I had so much fun building it and using my DRO that I wanted you guys to see it. So then I decided I should make it again. And I made a lot of little mods here and there just to get this going. And I'm super happy with it. Okay. Let's see here. Yep. There we go. Right, these guys, these casters, I am doing this all with, now normally I would, am I going to put a washer on that? I think I am going to put a washer on there. Is that a 3/8? Okay, so I'm not going to get a lot of room for the washer. Yep, just enough, good. I am using these high strength casters with threaded bolts on them, which isn't I don't commonly use these, and I don't know why, because I really dig them. I really, really like them. All right, so that is all 4 of them started. Let's get out my favorite thing, which is a impact driver with a bolt on it. Yeah. Right? Yep. Oh, I almost forgot. All right. So, I realized after building the first prototype that I was thinking about a tray up here. And then I realized, nah, no tray. I'm actually going to put a handle there. And so I made this handle. Now, this is cut out of the same 1-inch plywood. I used a 3/8 inch router on the sides. And then I have never tried painting wood like this before, but I painted it with marking fluid. This is the red lacquer used by machinists to die mark metal and do layout work on it. But I used it on plywood, and what you can see is that you can see all the layers of plywood. It's like this beautiful clear coat. And I only painted it like half an hour ago, and now with a little bit of the Krylon gloss coat, it's super glossy. So we're going to install it, and I really have to install it without damaging it. That's the goal here. Deuteronomy. Oh, this is so awesome. Okay, I am so pleased with this thing right now. Okay, yeah, I gotta load it up. Let's start with the 3-jaw chuck. This weighs about, honestly, about 40 pounds. Okay, so put that there. Nice. Here's the 4-jaw. There we go. And yeah. And lastly, the collet. This one only weighs about 20 pounds. It's the lightweight one in the group. Dude. I know I still need to pop that, put some glue in there, and suck it back down again. But this is really positive. Hold on, let's get a shot here. Look at that. Here's the thing that I'm really excited about with this one is, like I said, in this shop, I like a narrow footprint, right? I need a narrow footprint because space is a premium. Well, this is tall, but it's very, very thin, so it sucks in right there. Isn't that lovely? There is, yeah, there's my college storage. And the thing that's really nice is I could just throw a towel over that and then I don't have to worry about my lathe kicking all sorts of stuff on them. I can move this out. My prototype was just a tiny bit front heavy and I don't want any of these things falling and destroying my feet, which they would. So I've fixed the center of gravity issue here. I'm really pleased by this. Well, I, for one, am like so psyched about today's one-day build. This is one of my favorite pieces of furniture I have ever made. And Maggie thinks so too. She's very excited about it. Yes! All right, Maggie, should we go have some dinner? We're gonna go have some dinner. Thank you guys for joining me for this one-day build. See you next time. Thanks for watching that video. If you want to support us, one of the best ways you can do it is going to our merch store and purchasing one of our beautiful new posters. This one right here is called Elevations of Bear. And this is a compendium of 16 pages from my sketchbook when I was actively building my bear costume for San Diego Comic-Con a few years ago. What did I do with a bear costume at Comic-Con? I dragged around the carcass of Leo DiCaprio, sort of reversing things. Now this might be enough information for you to build your own bear costume, or you could just frame it and hang it in your house. Each poster is printed on a really lovely tactile heavy cardstock. Get your own by following the links below.